All right, so we're going to try hypothesis testing again. So we have in problem 13, it states, suppose 211 subjects are treated with a drug that is used to treat pain, and 52 of them develop nausea. Use a significance level of 0.05 to test the claim that more than 20% of users develop nausea. So part A states to identify the null and alternate hypothesis. Right, so we're going to do step one. So this will be the answer to part A. Null alternate hypothesis. So we denote the null as HO and the alternate as HA. So what would be my null hypothesis in this problem? What variable do I begin with?
Is it P equals?
That's right. So for the null hypothesis, you always start with P equals. The alternate is also going to have P, but the symbol, mathematical symbol is going to change. All right. So what do you think the population proportion is going to be equal to?
Is it 20%?
That's right, 20%, but 20% as a decimal is 0.20. Okay, what about the alternate hypothesis now?
Isn't it it doesn't equal point 20?
Careful, look back at the wording in blue. We're using a significance level of 0.05 to test the claim that more than 20% of users develop nausea. So because it clearly used the word more than, right, because it uses this key phrase more than, then you can use a right tail test, right? You can say P is going to be greater than 0.20.
Got it.
And we can make a drawing to show that this is all legit so far. So for step two, when I have to make the sketch, we're labeling out what type of tail test I have. So the greater than symbol indicates I have a right tail. And it also indicates that in the right tail, right? First, let me draw the bell shape. In our right tail, we're going to have the value of the significance level. So here, let's say this is my right tail. The area in that right tail is going to be 0.05. So I say alpha equals 0.05. And again, this is a right tail test. All right. Now we could proceed to steps 3 and 4. Steps 3 and 4 is the calculator steps. This is where you have to find the p-value. Sorry, before you find the p-value, you find the test statistic. So we call the test statistic z-test.
Yeah.
And we also find the p-value. But to get these two things in the graphing calculator, we use some of the information that we know about this problem. So first off, we do stat, then we select test, and then we do one proportion z-test. So I highlight the fifth option. Now, if you have data in here, you just clear it, right? So I'm just going to clear these things and just enter the new data. So our population proportion is 0.20. The value of X is 52. The value of N is 211. And we have the not equals case. So we hit calculate. And there you go. You got your Z value and you got your P value. So Z is approximately 1.69 if I round it to 2 decimal places. And the p-value that corresponds to our test statistic is 0.09. So with this 0.0, if I actually keep rounding this to 4 decimals, 0.09 0.0917. This represents the area to the right of your test statistic. So your test statistic is 1.69. The p-value is 0.0917, right? So if I were to look at my graph a little closely, let's say if this was my test statistic, this was my z-test value, then the area in that right tail is going to be 0.09. Right, so we have p equals 0.0917. So when you compare that p-value now to your significance level, is the p-value greater or less than significance level?
Less than.
Try again. P-value is 0.0917. Alpha significance level is 0.05. So is the p-value less than or greater than?
Oh, it's greater than.
It's going to be greater than. So because it's greater than, you would say that you failed to reject the null. Right. So if you look at the image, the only time that you would reject the null is if this p-value was less than alpha, meaning that you're inside of that blue region. If you fall outside of that blue region, then you automatically fail to reject. Does that make sense?
Yeah.
So the reason why the sketch is helpful is because when you have a case like this one, you can see that, okay, this blue region is like my critical or my decision region. If my p-value is inside of it, then I could reject the null. But if it's outside of the blue region, if it goes past it, then, or if it swallows up your critical region, then you fail to reject. All right, so step 6 is now how to write out your conclusion. So if you notice, by the way, the alternate hypothesis is the one that involves the greater than symbol. So this time that will be your claim. So whenever the alternate has the greater than or less than symbol, that becomes the claim of your statement, of your hypothesis test. So when we do the interpretation, we write it off based off of this claim. So we say that since we failed to reject the null, there is not enough. Ricardi, you gotta chill a little bit. There is not enough evidence to support the claim that whatever it was, that more than 20% of people who are they of users develop nausea. All right, and that's it.